In this video, we will study tossing a coin 10 times using permutation with identical items and with restrictions. A coin is tossed 10 times and the sequence of heads and tails is recorded. First question, what is the number of all possible outcomes or the number of elements in the sample space? We know that any element is ordered sequence of heads and tails, and this sequence is composed of 10 objects. Each time we toss a coin, we either get head or tail. So this problem is equivalent to withdrawing a ball named H or T out of this urn and replacing it. So let's do that. In the beginning, we withdraw this ball here randomly and we write down its name. Then we return it back and we withdraw again, and let's say we get this time tail. So we return the ball back and we withdraw again and we write the name of the withdrawn ball, and we keep doing that, withdrawing and then returning, withdrawing, returning, and so on until we get a sequence of 10 letters. So this is the sequence here, and we call this a generated random sequence. So we conclude that we are generating a sequence out of this set which contains two objects, head and tail. So what are the characteristics of this generation? Replacement is allowed, and the reason why the objects can be repeated in the generated sequence. And the other thing, order is important, and the reason why, if we have this sequence and we reverse it, so in this case this element is not equal to this element because of different order of letters. Now we have two conditions, replacement and order. So we can apply the formula of permutation with replacement of n objects taken r at a time. So n is the number of objects in this set, which is 2, and r is the sampling size, so we are generating sequence with 10 letters, so r is 10, and now we can substitute n and r into the permutation with replacement formula. So we substitute n with 2 and r with 10, and we get 2 to the power of 10, and this is equal to 1024 elements in the sample space. We can also derive the number of elements in the sample space using the multiplication principle for 10 disjoint set and in order. Each set is composed of 2 elements, head and tail. So we draw this table of events, and we have here 10 draws. So for the first draw we have 2 ways, and for the second 2 ways, and the third, and so on until we arrive at the final draw, which is the 10th draw. And now the number of all outcomes in order and with replacement can be obtained by multiplying all these ways together, and we get 1024 elements in the sample space. Question number 2, what is the probability that only the first 2 tosses will yield heads? So the first 2 tosses will yield heads, and we will have no other heads in the sequence. So we have to look for a sequence that starts with 2 heads and the rest of it doesn't have any head. So we conclude that these 2 heads are going to be fixed in position, they will not change, and the rest of this sequence can be permuted. And of course, if we permute these 8 tails, we are going to get 1. So we can also apply the permutation formula for 8 objects taken 8 at a time with 8 identical items, and that's equal to 1. So now the probability of the event is 1 divided by the total number of elements in the sample space, and that is 1 divided by 1024. Question number 3. What is the probability that the first 2 tosses will yield heads? So we may have all heads, and the first 2 are going to be heads. So these heads are going to be fixed in position, and now we can permute only the remaining 8 heads, and that would yield 1. We can also have a sequence with 1 tail in it, and starting with 2 heads. So these 2 heads are fixed in position, and now we can permute this 8-letter sequence with 1 head. Using the permutation formula, we can compute the number of possible permutation here. So we have 8 objects taken 8 at a time with 7 identical items and 1 identical item to itself, and that is 8. We can also have a sequence with 2 tails in it, and starting with 2 fixed heads here. So we have to permute this 8-letter sequence here, which has 6 identical items and 2 identical items. So we apply the permutation formula with identical items, and we get a 28 permutation. We can also have 3 tails in the sequence, and we do exactly the same, and we get 56 possible permutation for the case of 3 tails in the sequence. We can also have 4, and we get 70 possible permutation. We can have 5, and we get 56 permutation. We can also have 6 tails in the sequence. So we have here 2H in fixed position, and we can permute this 8-letter sequence with 6 heads, and we get 28 possible permutation. Or we can have 7 tails, and we get 8. Or we can have 8 tails, and we can get 1 possible permutation. We cannot assume the case of 9 tails, because in such case T will occupy this head cell here, and will end up with 1 head, and that violates a question which assumes that we should have 2 heads at the beginning of the sequence. And now we compute the probability of this event by dividing the number of elements in the event over the number of elements in the sample space. So this sum here is the number of elements in the event, and this is equal to 256 possible favored outcome divided by the number of elements in the sample space, and this is equal to 1 over 4, which is 0.25. Thank you for watching, and have a good day.